blue light special going on? All right, great. Okay, so this is 8.5, and now we need to deal with exponential functions. So yesterday, we reminded you guys of absolute value, and I showed you quadratic parabolas, U-shapes, and I showed you cubics, which are, again, that symmetrical type shape of the point of inflection. Today we want to do exponential functions. To be ready to do exponential functions, we've got to make sure that we can handle exponents. So I need to go through and we need to do a review here of the exponents and make sure that we're good with figuring out the value. So the first one's pretty simplistic. I think we all understand. I'm going to use my blue here just to stand out a little bit. I think we all know that a 2 cubed is a 2 times 2 times 2, right? So we're going to say that value is 8, right? 2 times 2 is 4 times 2 is 8. Piece of cake, no sweat. All right, so let's work to the right. So a negative 2 cubed in this setting, this is technically a negative, and then the 2 times 2 times 2. This isn't a negative 2 times a negative 2 times a negative 2. Though quite honestly, with an odd power, 1, 3, 5, 7, 9, 11, it'll turn out the same way, but for any even power, it's going to make a difference. So technically, this is negative 1 times 2 times 2 times 2. And so this thing is a negative 8. All right, the third one, we all know that 2 to the 0 power is 1. Again, the reason is it's the base divided by itself. But the base of anything to the 0 power is a 1, always. But it's the base. Just a little aside, you guys keep missing problems like this in the rules section. 7n to the 0 power. What is to the 0 power? What's the base? The n. What's 7 times 1? 7. But you keep missing that. And you miss it over and over and over and over again. That's not good. So we need to stop getting that chain of failure there. Okay, so now look at the next one down here on the left. So we have a negative 2 in parentheses. This is a negative 2 times a negative 2. We know what the base is because of the parentheses. And we all know that a negative 2 times a negative 2 is a positive 4. That thing ends up positive. But look at the next example to the right. This is a negative, if you want to think of it as a negative 1 times a 2 times 2. This is not a negative 2 times a negative 2. Can you clearly see the difference? The left one is in a parentheses. What is the base? The parentheses. The right one is really this, but we don't bother to write it this way because we don't need to write all that out. We know it's not the other one because there's not a parentheses there. And it's not a negative 2 times a negative 2. It's negative 2 times 2. And the answer to this one is negative 4. And if you mess that up, you're going to mess up these problems. Questions? Again, it has to do with applying the exponent to only its base. So you can see the left one gave you positive 4. The right one gives you negative 4. You can't mix them up. If you mix them up, you're going to be in trouble. All right, 2 to the negative 2, negative exponents. You should remember this is 1 over 2 squared, but some of you keep missing that rule as well. X to the negative a equals 1 over x to the positive a. Therefore, we're 1 over 2 squared, and this is a 1/4. You will not be able to do tonight's problems if you cannot do that. But I don't see why anybody can't do that. Okay, here's another one. What's the base this time? It's a negative 2. And again, that negative exponent becomes positive when you take it across the fraction bar. So this is 1 over a negative 2 to the positive 2. We already know negative 2 times negative 2 is 4, and that's also 1/4. Again, I'm expecting you to stop me at any point that you're not understanding and asking questions. And I'll try to explain it a couple different ways to get you to understand. If you don't ask me questions, I really can't help you. All right, the next one, obviously the exponent only goes to its base. So this is a 3 times 2 times 2, right? Or you could have just written right there 3 times 4. And this is obviously a 12. So what happens on the next one? Well, again, the exponent only goes to its base, right? So I have a 3 times. What should come next? Somebody raise their hand and tell me. Kyle? 1 over 2 squared. Correct. So this ends up being a 3 times 1/4. What's a 3 times 1/4? Say it if you know it. 3/4, right? 3 over 4. Again, you need to be able to do that if you're going to be able to accurately graph tonight's problems. A 1/2 squared. What does that mean? A 1/2 times a 1/2. Or you could say it this way, a 1 squared over a 2 squared. This is simply a 1/2 times a 1/2. 1 times 1 is 1, 2 times 2 is 4. That's also a 4th. Notice the 2, the one up above and that one are exactly the same value, 1/4. Two different ways of saying 1/4. Okay, this one can cause students some trouble. It's a 1/2 to the negative 2. The best way to do it is exactly the way I did the previous problem. Let's do a 1 to the negative 2, 2 to the negative 2. Isn't that what we just did in the previous one? We did the exponent to the top and bottom. What do you do with negative exponents in the bottom? You put them in the top and they're positive, right? So would you agree this is a 2 squared in the top? By the way, what's 1 to any power? What's 1 to the 5th power? What's 1 to the 8th power? What would a 1 to the negative 2 be? A 1 over 1 squared. What's a 1 over 1 squared? A 1. So that 1 to the negative 2 is just 1, and the answer is 4. So usually you don't even worry about the ones, and I don't. I just wanted to show you that we're being consistent. But again, you don't have to worry about 1 to any power. It's always 1. Positive or negative, it doesn't matter because again, you know 1 over 1 cubed is 1 over 1, which is 1. So a 1 to the negative 3 is 1 over 1 cubed, and that's 1. All right, the last one then, you could simply say this, can you not? 3 cubed. Oh, I'm sorry. I'm looking at a negative exponent, and it's positive. So this one is 1 cubed over 3 cubed, right? It's not a negative 3, it's positive 3 exponent. So 1 over 3 cubed. And be careful, 3 cubed is not a 9. A 3 cubed is 3 times 3 times 3. 3 times 3 is 9, and 3 times 9 is 27. So refer back to this section as you need to do the problems that we're going to get into, because we're going to graph, and you got to be able to do those to graph. Okay, so what's next? Number 1. Exponential functions are those where the variable is an, say it if you know it. Variable is an exponent. And you can see the form below in the blue box, right? Y equals a b to the x. Our variable is an exponent. Our x variable is an exponent. And then we got to remember the remember part. Anything can be graphed using n. Anybody remember? Anything can be graphed using an XY charts. Now, we learned a better way to graph lines, haven't we? Using slope-intercept form, y equals mx plus b. That's a more efficient way of graphing a line. But you know what? You can graph a line using an XY chart. That's what we did in the beginning. That's what we did first. How do you graph absolute values? XY chart. How do we graph exponential functions? XY charts. So anything can be graphed using an XY chart. All right. So positive functions. Positive functions. Don't worry a lot about this. The a is positive, and it goes with the a of the form right up above, right? That a is positive, and the b is greater than 1. Whenever that's the case, you're going to have a positive function. And quite honestly, you guys are mostly going to do positive functions. So that's our first example here. It is of a positive function. So look at example A here. There's no A shown, is there? There's nothing in front of the b to the x. So if there's nothing shown for A, what's the value of A? Not 0, because 0 times anything is 0, and everything would be gone. Gabe? No, not all the real numbers. Josh? It's a 1. We just don't show ones, and quite honestly, it's a positive 1. But we don't show ones, right? If you had an n, you wouldn't write 1n. You just write n, because n is 1n. We don't write the ones, but it's a 1. All right, so if you don't see an a value, it's because the a value is positive 1. And our b value is 2. So isn't our b greater than 1, right? The b is the 2, the base. The b is the base. And our base is a 2. So to graph this, we're going to use an XY chart. And I already chose the values for the XY chart. So remember, this is what you're doing. The first time, we're going to put in 0 for the variable. So you're going to write y equals 2 to the 0 power. And everybody says 2 to the 0 power is 1. So our first point is 0, 1. And I'm going to take my red out, and I'm going to plot on the graph the point 0, 1. It's right there, right? 0, 1 right there. Right? Everybody agree with that? We good with that? Okay. And so now I'm going to go to the next one. Now I'm going to use 1 for the x. So y equals 2 to the first power. And we all know 2 to the first power is 2. So it's a 0.12, and I'm going to take my red and out, and I'm going to plot the point 1 right and 2 up. And put that point on my Cartesian plane. Okay, you got the idea. Next is y equals 2 squared, right? I'm putting in the variable for the x value for the x, right? XY chart. Left values are x's. We're finding the y values. We all know 2 squared is 4. So now plot the point 2, 4. Okay, everybody do the next one. What do you get when the x is a 3? What do you get when the x is a 3? All right, if you're done, say it if you got it. 8, right? 2 cubed is a 2 times 2 times 2, right? A 2 cubed is a 2 times 2 times 2. So we'll plot that point, 3, 8. Now, is that a straight line? No. Exponentials are not straight lines, they're curves. So an exponential are curves. Practical applications of exponentials. We talked about in pre-algebra simple interest. And I mentioned that there's also a thing called compound interest. If you invest your money in an account that renders compound interest, the value of your account will be an exponential curve, just like the one we're graphing. And it's nice when, this is time and this would be money, the value. And as time goes by, the value goes up. People usually like that when that's their money that they invested. Okay? So a lot of other applications. If your population is in a growth, your population would be heading up. There's all kinds of applications. That's really Thursday's lesson. We got to finish our curve here, though. All right, so let's do -1. Y equals 2 to the -1. So what do you get when you get 2 to the -1? Say it if you know it. Okay, it's 1/2 or 0.5. I'm just going to stay in fractions. So can you plot the point -1, 1/2? It should go right about there, right? Right in line with our curve, doesn't it? And we'll do one more. Y equals 2 to the -2. So remember, 2 to the -2 is 1 over 2 squared. And what's that value? 1/4. So that one is going to be about there, right? All right, here's what happens. This curve forever gets closer to the x-axis, but it won't touch it until infinity. It'll keep getting closer and closer. The next value would be 1/8, and the next would be 1/16, and the next would be 1/32, and the next would be 1/64, and the next would be 1/128, and the next would be 1/256, and the next would be 1 over 512, and the next would be 1 over 1024. By the way, anybody know computers? You know the RAM, how RAM goes in computers? Exactly the same way, by the way. But anyhow, so this thing will not hit the x-axis until infinity. So we don't really want to cross it, and we want to try not to quite hit it as we draw our curve. We put arrows on both ends because the curve keeps going. And if I drew it well, this would be a nice, smooth, sweeping curve. That's an exponential function. They look like that. They have a flat part, and they have an up part. Now, you don't need to draw this, but really money is usually more like this. That's usually the curve on money, right? Because you're starting with zero money, right, at zero time and over time, but it takes a while to start getting to the upward part of that curve. However, the more money you invest in the beginning, then the quicker it goes up on that curve. All right, let's do another one. Clearly, the A value on this second example is a what? What's the A value? 2, right? And I'm going to put +2 just for clarity. And what's the value of B on this second one? 3, right? So we are greater than 1. It's the base. The B value is the base. The B is a 3. Right? Back up to the form here. Y equals A B to the X. Okay. So again, I did the exact same thing. I've got an XY chart. I chose the values for X, 0, 1, -1, -2. Remember, f of X is the same as Y, right? So I'm just going to put Y there. 2 times 3 to the 0. Now, if you need to do some extra steps, do it. But where do you end up with here? Right? Correct. This is a 2 times 1 or a 2. So our first point is 0, 2. The next one, y equals 2 times 3 to the first. And what do you get on that one? 6. Keep thinking now, okay? Hopefully I'm not going too fast. Keep thinking. Think through it. So we got the point 1, 6. So graph that point. Graph a 1, 6. Okay, you see how that shot up pretty quickly already? So when I was choosing my XY chart, I thought to myself, you know what, I'm not going to go any farther because this thing's shooting up pretty quickly. A 2 would be a 3 squared 9. 9 times 2 is 18. 2 is going to be an 18. A 3 is going to be 54, so it goes up quickly. So that's enough. I got that part of the curve. So I started then doing my numbers the other way, -1. So y equals, that should be black here, 2 times 3 to the -1. All right, be careful here. Remember, 3 to the -1 is a 1/3. So what's a 2 times 1/3? 2/3. So when we get -1, we get 2/3. So at -1, I'm putting a point at 2/3. And I'm going to do my last one. Y equals 2 times 3 to the -2. That's 2 times 1/3 squared. Rachel, are you writing? You already finished, went all ahead. Okay. All right. It's good if you're right. So 2 times 1/3 squared would be a 2 times 1/9. And this thing is a 2/9. As we get closer and closer again to the x-axis. So that's going to be really down there. So again, here's our curve. Don't forget, always arrows on both sides. Do you see the similarity in the curves? But one is steeper, right? The second one is steeper. You know what made it steeper? Two things made it steeper. The number 2 for the A and the fact that the base was bigger. 3 is bigger than 2. It's going to naturally be steeper. If we did 5, base would be really steep. Do like 9, it's like shooting up there really, really fast. So the value of the base can determine the steepness. All right, so let's go to the back. We'll never get all 3 of these examples in, but that's okay. All right, so negative functions. There's 2 possibilities. You can have the A negative and the B still greater than 1. Or you can have the A positive and the B will be between 0 and 1. The B will be between 0 and 1. So in our first example, we have a positive A. The A is +1. But isn't a half between 0 and 1? Right? And so the B value is between 0 and 1. All right, so we got to be careful when we graph this thing. Y equals 1/2 to the 0 power. Well, we can do that. Anything to the 0 power is 1. So this is a 1. So plot that point, 0, 1. Now look, this is the way I would do the problem if I were graphing it all on my own. I would have my XY chart, I'd do my first value, and I would plot it. Because looking at where my points are helps me to know what value to choose next. All right, I need another value. I'm going to go 1 to the right. I'm going to use 1. And I'm going to go y equals 1/2 to the 1. And we all know that's a half, right? So I go ahead and plot the point 1, 1/2. And I'm like, whoa, what's going on here? That looks different. I'm going to go another point further. What's going on here? I'm going to use 2. Y equals 1/2 squared. What's a 1/2 times 1/2? 1/2 times 1/2? 1/4, right? It's a 1/2 squared, which is a 1/4. Or just again, 1/2 times 1/2 is 1/4. This is a 1/4 for a 2. So now we're down here. What in the world? Well, remember, I said these are negative functions. So look, don't we know what's happening here? It's bottoming out. I need some stuff over here. So I'm going to do the next value to the left. I'm going to do -1. Y equals 1/2 to the -1. All right, now you got to remember what I did a minute ago. This is 1/2 to the -1, right? And 2 to the -1 is 2, right? It's 2 to the 1, which is 2. Now, again, you got to be able to do that or you're going to get these wrong. So -1 is a -1, 2. So let's plot that. -1, 2. It's right there. Huh. And we'll do one more. Y equals 1/2 to the -2. And so that's a 1/2 to the -2. 2 to the -2 is a 2 squared, and 2 squared is a 4. So we get the point, -2, 4. What would we get if we did -3? What's 2 cubed? It would be an 8, yes. Look at this curve. This is a negative curve. Goes like this. Don't we read left to right? What's happening to the y values, the output of the curve, as you go left to right? Look, start over here. This is a pretty high y value, right? Move left. Now you're here. Oh, our y value got lower. Move one left. Oh, now we're here. Our y value is getting even lower. Move one left. Our y value is getting lower, getting lower, getting lower. That's a negative function. You do not want to invest your money like that. Okay, that's not good. All your money is going away. All right, you're losing it all. You are a negative function. Negative functions end up going down to the right. Their y values are getting lower. Whereas when we did the positive functions, look what's happening to the right on these. We're shooting up, right? They're positive functions. As you go left to right, the output is getting higher. Those are positive functions. The other way are negative. All right. I can't do the middle one. It's a really funny looking curve, but that's okay. It's still a negative function. And that one is because, again, the b value is between 0 and 1, right? The b is a 0.2. So you just got to be careful and punch that in your calculator. Do a 0.2 squared. You get a 0.04, etc. I don't have time to deal with that one. Let's look at the last one here in the last couple minutes, C. So here, C is the one where we have a negative a value, even though the b is greater than 1, right? So what would you do to graph this? You'd start with an XY chart. What's always a great value to start with? 0 is better. Start with 0. Every one of mine started with 0, right? So this is what you do. Y equals -2 times 3 to the 0. So what do you get when you multiply -2 times 3 to the 0? -2. And I would right away plot my point at 0, -2. I do it right away. Helps me to see what's going on. All right, I'll use 1 next. Y equals -2 times 3 to the first. That's going to be a -6. I'm going to plot that point. 1, -6. Whoa. This thing's heading down, isn't it? It looks to me like this thing's curving down. I'm going to start using some of these values. See, this is the way you think when you graph. Look, you don't just sit there and do 100 points. You do a point, you plot it, and you look. And you do a point, and you plot it, and you look. Because you already know, we learned the shape. It's that curve. It's that curve. It's that curve. And I'm seeing some curve here. Now, you can do the next one. If you did, you know what you get? 18. -18. It's down here. You see that curve? I need to know this part. So I'm going to do -1. That's what I'm going to do. -1. Y equals -2 times 3 to the -1. This is a -2 times a 1/3. This is a negative 2/3. Do you agree? Negative 2/3? A negative 2 times a 1/3 is a negative 2/3. All right, negative 1, negative 2/3 is right about there. Huh. Let me go one more. Let's do negative 2. Y equals negative 2 times 3 to the negative 2. Y equals negative 2 times 3 to the negative 2. Oops, don't want that. So what do we end up with? Negative 2 times 1 over 3 squared. Negative 2 times 1/9. This is a negative 2/9. That's like right about here. Right? It's like right about there. Here's another way a negative curve can look. But isn't it going down as you move left to right? Right? That's another form of a negative curve. But you notice how we have that same shape, a flattened part and then the curved part, right? Flattens out, curves. That's the way these are. That's the way these are. That's the way these are. That is the way these are. All right, be careful now. We've got quiz tomorrow. Here's your work. Page 352. 1 through 5. 7, 8. 10, 12. 24. 31 through 34, no original. 31 through 34, no original.